Okay, so you've been asked to create a frequency histogram of the data from the table, and the process that I follow is to first figure out what my minimum value and my maximum value are. And we're doing plant height, so from plant height, if you look at that column of values, the minimum value is 0.6 centimeters and the maximum is 50. I then take the difference between the maximum and minimum, and that will equal 49.4. I then decide on my number of bends, and I generally kind of just start out thinking about kind of just a round number, so let's say 5 in this case, because we don't have a huge number of plants. So we'll do 5 here. And so I then figure out the values contained in each bin. So I'll take my maximum, my difference, divided by the number of bins that I want. And so in that case, that is 9.87. And then I generally round that to make numbers that are easier to deal with. And so here I'm going to go ahead and round that to 10. I then construct my bins and count the number of individuals in each bin. So to construct my bin, I start with the minimum, which was 0.6, and I'm going to round down. So I'm actually going to start with 0, and I'm going to go to 9.99999 right there, since each bin is worth 10. So 0, 10, 20, 30, 40, and 50 are my bins, and that will be 10 to 19.9999, 20 to 29.999, blah blah blah, to 39 to 49, and then to 59. Okay, so those are my bins. And what we're going to do then is count the number of plants that fit into those values. So from that column 0 to 9.9, I have 4, 10 to 19.9, 5, 3 for the next one, then 5, and then 8 for that last bin. Actually, this is 7, and then 1 for that last one. Okay, so I have my frequencies, and now I just need to draw my frequency diagram. So on the bottom is my trait, plant height. Don't forget your units. And then on the y-axis will be your frequency. Okay. And our frequency goes from, looks like 0 to 7. So I'm going to actually go 0 to 10. Just again, I like to round things. So 2, 4, 6, 8, and 10 there. And then for plant height, our first bin is 0 to 9.9, 10 to 19.9, 20 to 29.9, 30 to 39.9, 40 to 49.9, and then 50 greater than 50. We just draw up the bars. So this first one is 4, the second one is 5, then our third bin was 3, 5, 7, and 1. Okay, so that's the end of our frequency diagram. You were then asked to draw a scatter plot, which we're going to eventually turn into a line graph. So you need a y and an x, and our fitness estimate, in this case is seed weight, will go on your y-axis. Don't forget your units. And then on your x-axis is the trait that we think affects fitness. So in this case, we're looking at plant height. Again, remember your units in centimeters. And then to set up our scale here, we have our minimum value for seed weight is 0.254, so I'm going to set that at 0.2, and I can even do 0.25 there to start out with. And our maximum is 0.42, so maybe let's have that at 0.45 up there. And then for plant height, our minimum value is close to 0, and our maximum value is 50. And then we start plotting points. So our first point, alright, so I just filled in the axes there with my values, and my first point is at 0.3545 and 12.4, so that's going to be around here. Okay, and then my next point, 0.285 and 39.1. Okay, I'm going to continue to fill in those points. So once you plot all your points, it's time to put in your best fit line. And for that, you just, try to put your line in the middle of all of your points. And that's it. The last thing I've asked you to do is to argue for whether or not your population, or what type of selection it's under. This would be considered diversifying, because the extremes have the highest fitness value.